Welcome to solverfy.
So, there are two things that will primarily cause gases to not behave like an ideal gas. They are particle volume and particle interaction. Now, in a lot of cases, this is not real significant, especially at low pressures, large volumes, and just normal temperatures. But especially under high temperatures and high pressures, these can really start to differ. Particle volume means that there's going to be less volume between the particles, and that's what this term of the van der Waals equation accounts for. Particle interactions will actually affect the pressure, and while it's not a big deal when they're far apart under high pressure, when the density is higher and gas particles are closer together, it becomes a bigger deal. So this part of the van der Waals equation accounts for that. So just thinking about these, we can actually determine a lot about whether two gases will behave more or less like ideal gases. So let's start with comparing argon and xenon. These are actually both noble gases, so they are very inert, so they won't actually interact. The biggest difference is actually going to be their size, with argon being much smaller than xenon. And since xenon is larger, it's going to behave less like an ideal gas. Next, let's compare radon and mercury. So by volume, there's not a huge difference between these, but what is much more significant is going to be the interactions. Radon is a noble gas, and mercury is a metal, which means it's going to be a lot more reactive. So in this case, mercury will act less like an ideal gas. It's going to be more different. So now let's look at water and neon. So as far as volume, neon is going to be higher, is going to be greater. I just wrote that wrong. I said it right, that by particle volume, neon is going to be larger. But since neon is a noble gas and H2O isn't, and interacts a lot with each other, it's a toss-up between these two. So instead of just thinking about the particles, for this and the next one, we actually need to think about A and B. So these are constants in the van der Waals equation that will depend on the gas. And we can actually use these constants to determine how much something will differ from ideal gas behavior. Essentially, the bigger they are, the less ideal they are. So let's look at A and B for neon and for water. For neon, A is 0.211 and B is 0.0171. Water has an A of 5.46 and B is 0.0305. So from this we can see there's no contest. Water wins out. That looks like a heart. Hope you like that. Stuxum, we're also looking at water, and we're going to compare it with methane, which is CH4. So there are a lot of things that we could look at. We don't necessarily know much about the particle interactions. And particle volume, they're actually going to be similar. So instead, let's look at CH4 for A and B. So A for CH4 is 2.25, and B is 0.0428. So if we look at B, it's a little bit, CH4 is a little bigger, but A is so much smaller that in this case, we have to give H2O as being the winner of the non-ideal gas test. I hope this helped all of you, and please come back again.